Hi everyone. We're going to let universal set be positive integers less than 20, and P and Q are subsets of U, and they're given here. So we've got to answer these questions. So we'll start with the first two. We're going to write down the elements of set Q and P. So here's P. Now P, when you plug in the numbers, we want to have less than or equal to 0. So the best thing to do is test them. When we plug in 1, that's not going to be less than or equal to 0. Once you plug in 2, you're going to get 2 squared minus 24 plus 20, and that equals 0. So 2 is our start of P. And you can continue on and plug in numbers, and you will get all the way to 10. I'll just plug in 10 and see what we get. We'll get 100 minus 120. Then you get plus 20. That also equals 0. So after that, all the numbers are going to be greater than 0. So basically, we're looking at our set from 2 to 10. That's your P. Your Q is going to be a little easier. So your Q is just x squared, where it's in the universal set. So 1 squared is in the universal set. 2 squared is in the universal set. 3 squared is in the universal set. 4 squared is in the universal set. 5 squared is 25, and it's not in our universal set. So that is our 2 subsets of U. Now we're going to find the intersection of P and Q. So the intersection of P and Q. That means they're in both of them. So let's look and see what's in both. And that would be 2, 3, and 4. So 2, 3, and 4. All right, the next one is going to be P take away Q. So for that one, and let's just go ahead and do, I think I switched this. I'm going to do this one first. We're going to do P prime and Q prime. Let's do that one first. So P prime is going to be not P. So what we have in P that's not in P would be 1. Then we go all the way to 10. And then we have 11, 12. So not prime would be this. 12, 13, 14, 15, 16, 17, 18, and 19. Okay. Not Q is going to be everything but 1, 2, 3, and 4. So that's just going to be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So the intersect is where they're both, we have the same value. So for this one, that's going to be the intersection of not P and not Q is going to be 5, so let's match up the numbers here. So we have the ones that are the similar are going to be 11, and moving all the way up through here. So 12 all the way through 19. So this is going to eventually be 11, 12, 13, 14, 15, 16, 17, 18, and 19. All right, now, the reason I switched it is because I already had this one set up and I put it on the wrong slide. So basically, when you're talking about P, this is P minus Q. And it looks like this. So P minus Q is everything in P that's not in Q. So that would be P take away Q is going to be 5, 6, 7, 8, 9, and 10. So we have, we didn't use 2 because 2 was in Q. 3 we didn't use because that's in Q. 1 wasn't in P, so we didn't have to worry about it. 4 was in Q, so we can't use it. So everything we're using is everything that's not in Q. And then for the last one, we're doing our symmetric difference. This is your symmetric difference. And basically, it's in what's ever in P and what's ever in Q, but not both. So we can't use this one. So when you do your P, your symmetric difference of P and Q, or P delta Q, that's going to be 1, 5, 6, 7, 8, 9, and 10. Put 9 and 10 here. All right, so let's look at it some more. So we have 1 is in Q, but not in P. 5 is in P, but not in Q. 6 is in P, but not Q. 7, 8, 9, and 10 is in P, but not in Q. So basically, the ones that would be in this section that we can't use are the intersection, which is 2, 3, 4, and the 2, 3, 4. We use everything else. And that's it. Thank you. Have a nice day. Bye-bye.